All right, friends, we got a short unit here on transformations. We're going to start with translations and reflections today, and then we'll move on to rotations. So what is a transformation? Let me write that word right here. Transformation. An operation that maps an original figure called the pre-image onto a new figure called the image is a transformation. That's all it is. So the pre-image is the one you start with. The image is what you get after you do the transformation. And what can a transformation do for you? Well, it can change the size or shape. Well, I take that back. I don't want to say shape. It can't change the shape. It can change the size or position. Size or position of a figure. All right. Now, if we have a transformation in which the pre-image and the image are congruent, that's what's known as an isometry. Most of the transformations we'll be dealing with are isometries, but some are not. That's a good term to remember. All right, so now we know what a transformation is, so let's start with a translation. What is a translation? It's a transformation that maps all points of a figure of the same distance in the same direction. So if you look here, let's see, where is our, and generally when we take a pre-image and we do a transformation on it, we will name the image with a little prime. So if we take point A and we map it somewhere, we're going to call it A prime when we get finished with it. So that means in this little picture here, ABC is our pre-image, and then when we translate it, all the points A, B, and C, the same distance in the same direction, we get A prime, B prime, C prime. Okay, so let's look at this example here. Each point on the black square moves how many units to the right? Well, it moves 4 units right and 2 units down. So what we would do is we would want to write a rule for this translation, and here's how it would look. So we're putting X and Y because we're moving it in the X direction and the Y direction. And what happens is the X direction is 4 to the right, the Y direction is 2 down. So that's how we would write our rule for that. Okay, let's write a rule for this one here, going from the black as the pre-image to the blue as the image. So we're definitely going to the right, so I know it's going to be X plus something. I just have to count what it is. So let's look at R. I'm over here, 1, 2, 3, 4. I'm at -4, and R goes to +4, so that's 8 units. So that's going to be X plus 8. And we also move down. Let's see, so R is at -2, and it goes down to -3, no, goes down to -4. Hold on, sorry, R is at -1. R is at -1 in the Y direction, and it goes down to -3. So that means we got to subtract 2. So there is our transformation rule when we're talking about a translation. All right. What if we do more than one transformation at a time? Well, we call that a composition. Composition of transformations is a combination of 2 or more transformations. In a composition, you perform each transformation on the image of the preceding transformation. So for instance, if you were going to map A onto A prime, then if you were doing a third or a second transformation, you would map A prime to its new image, and it would be A double prime. Okay, we just keep adding on the primes to rename our new image. In general, the composition of any two translations is just going to be another translation. So in other words, let me go back up here to this other page. If I had taken this image here, and if I had moved it 2 more to the right and 4 more down, I could just write one rule that mapped the original figure to that final destination. That's all that statement is saying there. Okay, so that's it for translations. Not very difficult. So let's talk about reflections. A reflection across a line R, which is called the line of reflection, is a transformation with these two properties. If point A is on line R, in other words, if point A is on the line of reflection, then the image of A is itself. So A equals A prime. All that's saying, guys, is that if the point that you're reflecting is on the line of reflection, it's going to stay on the line of reflection because all the points have to be equidistant. And when you have a reflection, every point that you reflect in the pre-image has to be the same distance away from the line of reflection in the image. Okay, and the second point is if a point B is not on line R, then the line of reflection is the perpendicular bisector of BB prime. Okay, that's a little bit more difficult to understand, but let's look at our points here. Let's look at the points they're talking about. Point B, okay, and when I reflect it over this line R, our line of reflection here. Okay, remember what we said. Point B, the new point, the image point B prime, has to be equidistant from the line of reflection. So I know that this distance and this distance are the same. What I also know is that this line of reflection is the perpendicular bisector of this segment that connects the pre-image point to the image point. That's all that point 2 is saying to you right there. Okay, so the rest of what we got are some examples. I'll probably do 1 or 2. Ooh, there are a whole lot of examples. I'll do a couple and I'm going to let you pause and do the rest. All right, let's start with this one. Graph the following reflections. Triangle ABC. Hey, you know what we need to do right here? I want you all to pause the video and go in and draw all of your pre-images. That's going to save us a whole lot of time. So that's what I'm going to do for all the rest of the problems. I'm going to draw the pre-images and then I will meet back here with you. Well, that took a little while to draw all those, but you'll be glad you did because now we're just going to roll on through. Okay, what are we doing? We're reflecting here in the x-axis, so I highlighted my line of reflection in. You always want to do that. And then what do I know? So number 1, remember the 2 things about reflections. Number 1, if a pre-image point is on the line of reflection, it'll stay on the line of reflection. We don't have that here. And then the point number 2 that we wanted to remember is that the line of reflection is the perpendicular bisector for the segment that connects the pre-image point to the image point. So really what we need to do is put some points down here that are equidistant from this line of reflection. So we're going to start with A. It's 2 units above the line of reflection. So A prime is going to be 2 units below. B is, let's see, 1, 2, 3, 4, 5, 6, 7, 7. So I got to come 7 down to get B. 1, 2, 3, 4, 5, 6, 7. So there's B prime. And C is above the line 1 unit, so it's going to be below the line 1 unit. And then I just connect all my vertices, and I've got that triangle ABC reflected in the line y equals 0, which is the x-axis. And then you want to write your vertices in here, and we'll do that quickly. It's -4, -2, 4, -7, and 5, negative 1. Hey, what do you notice when you got something reflected in the x-axis? None of the x-coordinates changed, did they? None of the x-coordinates changed. It just became x negative y. Good thing to remember there. Okay, what do we have next? Rectangle, PQRS with those vertices, and we're reflecting in the y-axis this time. Okay, got that all drawn in here. And so let's see, what do? We basically just got to count how many units away from the line of reflection each point is. So that means, let's see, that's 2. So Q prime, going to come over here. P prime, going to come over here. R prime, let's see, R is at 8, so it's going to come over to negative 8. And S is over there at 7. So it's going to be over here at negative 7. Let's see, what was that? R prime and S prime. There's our new rectangle reflected over the y-axis. So the new vertices will be negative 1, 2, negative 2, 5, negative 8, 3, and negative 7, 0. And what do you notice this time that doesn't change? It's the y-coordinates. So this, when you have a reflection in the line x equals 0, which is the y-axis, it's going to be negative x, y, right? Okay, here's one. It's just a different line of reflection. It's still a vertical line, so I want you to do that one on your own. At the end of this lesson, after we go through the rest of these, I'll come back and put the solution in for you for that one. Let's look at this one here. We haven't had one where we don't have a vertical or horizontal line. So what do you think we're going to do here? Let's see. I've got this triangle. We're reflecting in the line y equals negative x. And remember, so what we got to do is we got to maintain the distance to the line of reflection of our pre-image point to the image point. So if I go, let's take point T here. If I go up, I got to go 1, 2, 3. I got to go up 3 units, right? 1, 2, 3 to get to that line. So if I do that, if I go up, because the line that connects T and T prime has to be perpendicular to the line of reflection, then I'm going to have to go over 1, 2, 3 to find my T prime point, right? So if that's T prime, look, if I sketch in this segment that connects T and T prime, then the line of reflection is indeed the perpendicular bisector. So that's how we're going to find the rest of these points. Let's look at point U. All I have to do is go up 1 to get to the line of reflection. So that means I'm going to go to the right 1 to get U prime. Okay, and then S, I got to go up 1, 2, 3, 4, 5, 6, 7. So I got to go over 1, 2, 3, 4, 5, 6, 7. S prime. So there is my reflected triangle over that line. And again, if I draw in all the segments that connect the pre-image points to the image point, you will see that that golden line there, the line of reflection, is the perpendicular bisector. And let's see, I don't think I have the coordinates for that new, oh yes I do. The coordinates are 6, 1, 0, 0, negative 3, and 4, negative 3. So I want you to tell me, what is that rule for reflecting in the line y equals negative x? I want you to see if you can figure that out for yourself, just like we did on the previous two. And again, when I come back, I'll fill that in for you. Okay, this one is a simple translation. We're going to take all these points. We're going to go left 1 and down 5. So I'm going to trust you to be able to do that. And what you're going to end up with is -5, -3, and 4, -6, -3, 7. Because right, all we got to do is subtract 1 from all of our x coordinates. Right, there's a negative there, don't miss that. And we got to subtract 5 from our y coordinates. So you be sure to sketch that translated triangle in there. In the interest of time, I'm not going to do that. Okay, again, here's another translation. I want you to pause here and do that one. And I'll come back and put the answer in for you. Let's go on down here and let's see what we got to do. I feel like I skipped. Didn't I skip something? Oh yes, they're over there. Okay, this one says write a rule. Write a rule for the translation. Oh, okay. So all we got to do here is we know we're going to the right, so it's going to be x plus, and let's see, d is over here at 1, 2, 3. D is -3, 1, 2, +3. So let's see what d prime is. 1, 2, 3, 4. D prime is 4. 1, 2, 3, 4, 5, 6, 7. So how many steps to the right does it take me to get from -3 to 4? 7, I believe. And to get from 3 to 7, it's going to be y plus 4. So actually, that should have been right there. All right. I want you to give these a try on your own. You got to do a composition of transformations. I believe you can do it. I'm going to let you pause here and do that, and then come back and I'll have all these answers up for you that I promised. Okay, wow, that was a lot to go back to. I don't remember if I started here or if I'd already done this, but anyway, this is the one. Oh, I did say, yeah, this is the one right after we found the negative xy rule. Then we're reflecting in the line x equals -1. There's no rule for that. I mean, you could use the x equals 0 rule, or the y-axis, and then you could shift everything to the to the left one. But anyway, that's what that one looks like. Make sure you got that taken care of. All right, and then we went down here and we did do this one, but I asked you to please see if you could figure out what this rule was if I'm reflecting in the line y equals -x, and that's what happens to your coordinates. Okay, next problem, I believe we did that one. This one here, we're just doing a translation of that trapezoid, so we shift all the points to the right 4 and down 1. That's what we get. This one, we did that one together. And then here we were doing a composition. So first, I reflected in the line y equals x. You can use your rule for that to get the coordinates. And then we just did a translation. So we reflected, let's see, here was our purple was the pre-image. Okay, the green was the image, and then I translated the green over to the left 3 and down 7. So there's your very final image there. Okay, and then finally we had another one of those, except in the reverse order. We did the translation first, then the reflection, and of course this is a reflection in a horizontal line, so it's much easier. So there's what you got. Okay, so make sure that you're okay with translations and reflections. Next, we're going to move on to rotations, I believe. You should still be doing all the work in your packet until we meet again.